Hello, hello, hello. Today we will be doing system design part 2. As you all know that I am trying to finish this book and yeah, I will leave for dinner at 8:15, so I have around 55 minutes or something क्योंकि 5 मिनट पहले जाना होगा. तो yes, let's do it. So मैंने इससे पहले कहाँ तक करा है. This was Sunday's contest. Yeah, rate limiter पे था मैं. I was at rate limiter. उसमें मैंने एक दो टेक्निक्स देखी थी. I saw I did कौन सी I did the one bucket वाली, the one with the buckets where we have a bucket capacity and every request we like the capacity decreases by one, and in the end when there is nothing so request won't be processed. फिर इसके बाद we have a queue which follows FIFO, and it has a regular. It's just like bucket, but but everything comes out at regular intervals. And after that, I stopped. मतलब I learned about rate limiting. Uh, yeah, this I read all this. ये सब yeah, leaking bucket algorithm था Q वाला, and before this we had इसको पूरा ही कर लेता हूँ. ठीक है. So yeah, let's. So we have some algorithms for rate limiting. What is rate limiting? Rate limiting is basically like uh, limiting the number of requests a user can send to the servers. So it is of two types, like client side. We can do client side rate limiting and we can do server side rate limiting. Client side rate limiting is done at the client end, and this is a risky thing because like clients can use malicious techniques to uh, manipulate the rate limiting being done, and they can change it like unki side pe they can do anything, right? So we generally prefer server side rate limiting में हम एक rate limiter use करते हैं servers के साथ. And rate limiter is basically a device that limits the request sent. So for example we have DDoS attacks where we have a lot of requests being sent and the server is totally occupied and the site just crashes or just doesn't load. So yeah, so we put the rate limiter with the servers, right? And DDoS की full form क्या थी यार? I forgot. What is the full form of DDoS? इसमें था ready to put a rate limiter. Yeah, too many requests, and it just sends a message to the server that they send too many requests. So this is also one major like advantage of doing server side पे, क्योंकि HTML response हम भेज सकते हैं. जैसे यहाँ पे इन्होंने 429 too many request response भेज दिया. Evaluate your current technology stack such as ये तो बेकार है, पता नहीं कहाँ गया DDoS. Okay man, DDoS, DDoS. What? Yeah, I'll just do algorithms for rate limiting. Yeah, okay. So algorithms for rate limiting. Rate limiting can be implemented using different algorithms and each of them has distinct pros and cons. Okay, 1 second. Okay, so even though this chapter does not focus on algorithms, understanding them at high level helps to choose the right algorithm. Yeah, तो हम high level पे समझ लेते हैं सारे. So first is the token bucket algorithm. The token bucket algorithm is widely used for rate limiting. It is simple, well understood, and commonly used by internet companies. Both Amazon and Stripe use this algorithm to throttle their API requests. Okay, so what was this? Ticket to fuck token bucket algorithm. So token bucket algorithm इसके बारे में पढ़ते हैं. A token bucket is a container that has a predefined capacity. Tokens are put in the bucket at preset rates periodically. Once the bucket is full, no more tokens can be added. As shown in the figure 4.4, the token bucket has a capacity of 4. The refiller puts 2 tokens in a bucket every second. Once the bucket is full, extra tokens will overflow. Okay, cool. Each request consumes 1 token. When a request arrives, we check if there are enough tokens in the bucket. Okay, if there are enough tokens, we take 1 token out for each request and the request goes through. If there are not enough tokens, the request is dropped. Yeah, so basically we have some requests coming in, right? And we have a token bucket जिसमें certain capacity है of tokens. So we have certain capacity of tokens, इतने tokens इसमें होंगे. And we also have a rate of recharge where we add token at certain time intervals. So अभी यहाँ पे 4 tokens हैं and कोई request नहीं आ रही. So if we try to add some certain amount of token, वो सारे overflow हो जाएंगे. But if we have some request, तो वो request आएगी, it will consume 1 token and token like this will go away. और अभी अगर इंटरवल पास नहीं हुआ है तो कोई टोकन नहीं आएगा एंड या दिस रिक्वेस्ट विल बी प्रोसेस्ड. फिर से लगा ले जैसे वी हैव 3 रिक्वेस्ट एंड दीज 3 विल बी प्रोसेस्ड एंड नाउ द टोकन बकेट इज लाइक एम्प्टी. और अभी तक वो पीरियड ऑफ टाइम नहीं आया है जिसमें रिचार्ज होगी एंड रिचार्ज कैपेसिटी भी हमने डिफाइन करी है लेट्स से लाइक 3 और इसकी कैपेसिटी है 10. तो लाइक इट्स कम्प्लीटली एम्प्टी नाउ. तो अब अगर रिक्वेस्ट आएगी इट विल बी रिजेक्टेड बिकॉज there are no more tokens. Yeah, so enough tokens, yes, forward requests, and if there are no, they will just drop the requests. Okay, yeah, okay, cool. Yeah, ठीक है. The token bucket algorithm takes 2 parameters, bucket size and refill rate. Yeah, so there is a bucket size, 2 parameters. The token bucket algorithm takes 2 parameters, bucket size and refill rate, right? So it takes 2 parameters. First one is the bucket size. Bucket size is basically the capacity of the bucket, the maximum number of tokens that are allowed in a bucket. And the refill rate is the number of tokens put in the bucket every second. Number of tokens that are put into bucket every second. Oh my god, my writing, bro. Damn. थोड़ा धीरे लिखता हूँ. Every second, every day. Okay, how many buckets do we need? This varies and it depends on the rate limiting rules. Here are a few examples. It is usually necessary to have different buckets for different API endpoints. Okay, different buckets for different API endpoints. Cool. For instance, if a user is allowed to make 1 post per second at 150 frames per day and like 5 posts per second and three buckets are required uh, for each user because he is doing 3 tasks. If we need to throttle requests based on the IP address, each IP address requires a bucket. If the system allows a maximum of 10,000 requests per second, it makes sense to have a global bucket shared by all requests. Pros: the algorithm is easy to implement, memory efficient, token bucket allows a burst of traffic for short periods, a request can go through as long as there are enough tokens left. And cons are 2 parameters in the algorithm are bucket size and token refill rate, however, it might be challenging to tune them properly. Okay, so the second algorithm that we have is leaking bucket algorithm. The leaking bucket algorithm is similar to the token bucket except that requests are processed at a fixed rate. Okay, so my requests are processed at a fixed rate. So this is the leaking bucket algorithm, right? Leaking bucket algorithm. In leaking bucket algorithm, the requests are processed at a fixed rate. It is usually implemented with the first in, first out FIFO queue. The algorithm works as follows. When a request arrives, the system checks if the queue is full. If it is not full, the request is added to the queue. ठीक है, otherwise the request is dropped. Requests are pulled from the queue and processed at regular intervals. Yeah, तो इसमें यही डिफरेंस है कि इसमें जो भी होता है रेगुलर इंटरवल्स एंड रेगुलर फिक्स रेट पे होता है और उसमें ऐसा कुछ नहीं था. It was just buckets and tokens. तो we have some requests and bucket is full नहीं है तो we put them in the queue and they are processed at a fixed rate in a P4 order. Leaking bucket algorithm takes 2 parameters, bucket size and outflow rate. Bucket size is it is equal to the queue size. The queue holds the request to be processed at a fixed rate. Outflow rate, it defines how many requests can be processed at a fixed rate, usually in seconds. ठीक है. How many requests can be processed at a fixed rate? Outflow rate how many requests can be processed at a fixed rate at a fixed rate. How many requests कितनी request process हो सकती हैं at a fixed rate, usually in seconds. Okay, bro. Shopify and e-commerce website use leaky buckets for rate limiting. Pros हैं इसके memory efficient होता है given limited queue size and requests are processed at a fixed rate. Therefore, it is suitable for use cases that in which a stable outflow rate is needed. Cons हैं a burst of traffic fills up the queue with old requests, and if they are not processed in time, recent requests will be rate limited. Yeah. They there are two parameters in the algorithm and ठीक है ये तो सब में ही है. Fixed window counter algorithm पे आते हैं. Fixed window counter algorithm works as follows. The algorithm divides the timeline into fixed size time windows and assign a counter for each window. Each request increments the counter by one. ठीक है. The algorithm divides the timeline into fixed size time windows and assigns a counter for each window. ठीक है. So we have a timeline और इस algorithm ने उस timeline को divide कर दिया fixed size windows में and each window is assigned a counter. Okay, cool. Once the counter reaches the predefined threshold, new requests are dropped until a new window starts. Okay, let us use a concrete example to see how it works. In figure 1.8, the time unit is 1 second and the system allows a maximum of 3 requests per second. In each window, if more than 3 requests are received, extra requests are dropped. Okay, got it. So these are the number of requests and it allows हर एक window है of 1 second and it allows 3 requests. So on the second window, we had 6 requests, उसमें से 3 process हुई and 3 are rate limited requests. Similarly, on the third window, the 2 second window, उसमें हमारी 4 requests आई. One is rate limited request and 3 are successful requests. And fourth में 2 requests आई, both are successful requests. And similarly for fifth window. A major problem with this algorithm is that a burst of traffic at the edges of time windows cause more requests than allowed quota to go through. Consider the following case. In figure 4.9, the system allows a maximum of 5 requests per minute. Okay, and the available quota resets at the human-friendly round minute. As seen, there are 5 requests between 2 and 2:01 and 5 more requests. Okay, for the 1 minute time window between 2:30 and 1:30, 10 requests go through. This is twice many as allowed. Damn, this is like a bypass or something, huh? Pros, memory efficient, easy to understand, resetting of available quota at the end of the unit time. Okay, a spike in traffic window can cause. Okay, cool. आगे समझ ठीक है, तो आसान था. Sliding window log algorithm. As discussed, wait, इसका क्या नाम था? विंडो फिक्स विंडो काउंटर एल्गोरिथम. तो अभी तक कर लिया टोकन बकेट, लीकिंग बकेट, फिक्स्ड विंडो काउंटर एल्गोरिथम. फिक्स्ड विंडो काउंटर एल्गोरिथम. Oh my god, I misspelled this. That is embarrassing. ठीक है. Sliding window log algorithm है. This was window counter algorithm, right? Right. Fixed window. Oh my god. Fixed window counter algorithm. ये वाला है स्लाइडिंग विंडो वाला. स्लाइडिंग विंडो लॉग एल्गोरिथम. As discussed previously, the fixed window counter algorithm has a major issue. It allows more requests to go through at the edges of the window. The sliding window log algorithm fixes this issue. It works as follows. The algorithm keeps track of request timestamps. Wait, did I even start it? Oh my god. कितना टाइम हो गया? I'll skip there. 14 minutes, right? So it would be 14, 24, 14 is like 10 here, right? इतना कर देते हैं. Man, I'm so dumb, bro. Sliding window log algorithm. As discussed previously, the fixed window counter algorithm has a major issue. It allows, yeah, पता है भाई. Sliding window log algorithm fixes this issue. It works as follows. The algorithm keeps track of request timestamps. Timestamp data is usually kept in cache, such as sorted sets of Redis. The algorithm keeps track of request timestamps. ठीक है. When a new request comes in, remove all the outdated timestamps. Outdated timestamps are defined as those older than the start of the current time window. Add timestamp of new request to the log. If the log size is the same or lower than the allowed count, a request is. Yeah, man, explain me. What the hell was this, bro? We explain the algorithm as follows. ठीक है. Allows 2 requests per minute. Okay, the first request came. फिर the second request came 1 and 1:30 पे, and then तीसरी आने की कोशिश won't be able to come. Um, in this example, the rate limiter allows 2 minutes. Usually, Linux timestamps are stored in the log. However, human readable representation of time is used in our example for better. The log is empty when a new request arrives at 1:01. That the request is allowed. ठीक है. A request arrives at 1:00:30. The timestamp is inserted into the log. After the insertion, the log size is 2, not larger than the allowed count. Thus, the request is allowed. A request arrives at 1:50 and the timestamp is inserted into the log. After the insertion, it is 3 and larger than, thus the request is rejected even though the timestamp remains in the log. A new request arrives at 1:01:40, but requests sent before 1:01:40 are outdated. Two outdated timestamps are removed. After the remove operation, the log size is okay. I got it. So this was sliding window log algorithm, right? Sliding window log algorithm. What? Sliding window log algorithm. Okay, आ गया समझ. Sorry. Sliding window log algorithm. Yeah. So what we do in this, right? We have a window, and a window keeps track of timestamps, and these timestamps are stored as logs. So let's just say we have a window which is completely empty right now. The first request came at 1:00:01. So since the maximum allowed window size यहाँ पे इन्होंने माना है 2, since इसका log का size अभी 0 है, so we inserted. अब log का size हो गया 1. Another request came, let's just say at 30. log का size 1 है, so it is allowed. तो यहाँ पे एक और टाइम स्टैम्प स्टोर कर दिया विंडो में. log का साइज 1 है. what the fuck am I saying? विंडो का साइज 1 है. टोटल टाइम स्टैम्प्स, टोटल लॉग्स का साइज 2 है. अब टोटल लॉग्स का साइज 2 है. So let's just say that another request tries to come in, right, at 1:50, but like log ka size as we can see is 2. So what happens is, right, we have these two logs with us. What happens is ye wala it will take, but it won't process ये वाली request. ये दोनों request हैं, they will be processed. इनका तो हो गया, they are processed and will be removed from the window. तो इनको remove कर दिया. What we have now is this वाली request और इसको store कर लिया टाइम स्टैम्प में. एंड नाउ लेट्स जस्ट से एक और रिक्वेस्ट आ गई 7 ऐसे कहीं पे. नाउ विंडो का साइज है 2 और अब सेम चीज कंटिन्यू होगी यहाँ से फॉर फर्दर रिक्वेस्ट. So this was sliding window log algorithm. We store timestamps in a log. Rate limiting implemented by this algorithm is very accurate. In any rolling window, request will not exceed the rate limit. The algorithm consumes a lot of memory because even if a request is rejected, its timestamp might still be stored in the memory. Yeah. Sliding window counter algorithm. The sliding window counter algorithm is a hybrid approach that combines fixed window counter and sliding window log. Sliding window counter. The algorithm can be implemented by two different approaches. We will explain one implementation in this section and provide reference for the other implementation. Okay. So rate limit is 5 requests per minute, and we have a time and number of requests. Previous minute and current minute. Rolling minute is 70% and 30%, and current time is this. So in total, there are 8 requests. Assume the rate limiter allows a maximum of 7 requests per minute. There are 5 requests in the previous minute and 3 in the current minute. For a new request that arrives at 30% position in the current minute, uh, okay, for new okay the number of requests in the rolling window is calculated using the following formula: request in the current window plus request in the previous window times overlap percentage of the rolling window and previous window. So we'll have 3 plus 5 times 5 times 0.1. ठीक है. Okay, cool. So ये हमारी पूरी विंडो है, and this is consuming 70% of the total window. Since the late limit allows the current request can go through, however, the limit will be reached after one more request. Due to space limitation, but not smooths out spikes in traffic because it smooths out spikes in traffic and memory efficient. This line I have read so many times. Smooths out spikes in traffic. Like, bro, I know, bro. It only works for not so strict loop back window. It is an approximation of the actual rate because it assumes requests in the previous window are evenly distributed. However, this problem may not be as bad as it seems. According to experiments done by Cloudflare, only 0.003% of the requests are wrongly allowed and rate limited among the 400 million requests. That's like that's like nothing. High level architecture. Okay, let's see. आई थिंक यही लास्ट टॉपिक हो पाएगा. क्या टाइम है? 35 हो रहे हैं हम तो. या बट पहले ब्रेक से पहले आई थिंक यही होगा. राइट. फिर स्टेप 3 शुरू कर देंगे इस ब्रेक के बाद. पता नहीं. द बेसिक idea of rate limiting algorithms is simple. At the high level, we need to counter we need a counter to keep track of how many requests are sent from the same user, IP address, etc. If the counter is larger than the limit, the request is disallowed. Where shall we store counters? Using the database is not a good idea due to slowness of disk access. In-memory cache is chosen because in-memory cache is chosen because it is fast and support time-based expiration strategy. For instance, Redis is a popular option to implement rate limiting. Okay, Redis is a popular option. What? Redis is a popular option to implement. Redis. Redis. Redis is a popular option to implement rate limiting. Okay, it is an in-memory store that offers two commands, incr and expire. Incr, it increases the stored count by 1, and expire, it sets a timeout for the counter. If the timeout counter, the counter is automatically okay. Client and rate limiter middleware. We have API servers and we have Redis. Redis के साथ two-way communication. And the client sends a request to the rate middleware. The rate limiting middleware fetches the counter from the corresponding bucket in the Redis and checks if the limit is reached or not. If the limit is reached, the request is rejected. If the limit is not reached, the request is sent to the API servers. Meanwhile, the system increments the counter and saves it back to the Redis. दो चीजें होती हैं INCR and INCR in EXPR. इंक्रीमेंट विच इंक्रीमेंट द काउंटर एंड एक्सपायरेशन डेट जब रीच हो जाती है तो ये कॉल होता है. इट क्रिएट्स एन एक्सपायरेशन डेट फॉर ईच ऑफ द काउंटर. ठीक है. कूल कूल कूल. ऑलमोस्ट इन टाइम राइट. नाइस. तो लाइक क्लाइंट ने रेट लिमिटर मिडलवेयर को भेजी, रेट लिमिटर मिडलवेयर ने रेडिस को भेजी, रेडिस सेंड्स द रिजल्ट की काउंटर इफ इट हैज एक्सीडेड तो वो रॉन्ग भेज देगा और रिक्वेस्ट रिजेक्ट हो जाएगी. एंड इफ द काउंटर इज इंक्रीज तो वो उसका टाइम स्टैम्प स्टोर कर लेगा नहीं, टाइम स्टैम्प स्टोर नहीं करेगा। व्हाट डज इट स्टोर? एक्सपायरी स्टोर कर लेगा एंड वापस भेज देगा मिडलवेयर को, एंड एपीआई सर्वर की रिक्वेस्ट वापस चल जाएगी। If the limit is reached, the request is rejected. If the limit is not reached, the request is sent to the API servers. Meanwhile, the system increments the counter and saves it back to the Redis. ठीक है, the request is sent to the API servers. If the limit is not reached, the request is sent to the API server, and meanwhile, the system increments the counter and saves it back to Redis. Okay, cool. Now we have a 5 minute break, which I don't want to observe, but कर लेता हूँ, I guess. Bro, how much time is left, bro? 3 minutes. 3 minutes में गाना गा लेते हैं कोई. What song should I sing? Let's sing. कौन सा अच्छा गाना है? 3 मिनट तो like decide होने में लग जाएंगे, bro. ये हो गया ना? भाई क्यों खोला? What is this? कोई अच्छा गाना. Love Yourself, Justin Bieber. बहुत टाइम हो गया सुने में. कहाँ है इसके lyrics? I think I remember them. For all the time, नहीं. For all the times that you rain in my parade. गलत बोल दी फिर. For all the times that you rain in my parade. Was wrong and try to make me forget where I came from. And I didn't want to write a song, 'cause I didn't want anyone thinking I say care I don't, but you say hit my phone up, and baby I'll be moving on. And I think you should be something I don't wanna hold back. Maybe you should know that my mama don't like you and she likes everyone. And I never like to admit that I was wrong. And I've been so caught up in my job, didn't see what's going on, but now I know. I'm better sleeping on my own, 'cause if you like the way you look that much, oh baby, you should go and love yourself. If you think that I'm still holding on to something, you should go and love yourself. For all the times that you made me feel small, I fell in love, now I feel nothing at all. I never felt so low, and now I was vulnerable. Cause I feel too late, you break down my phone. Bye, 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 bye. Bye, Justin Bieber. Bro, I just leaked my code for his account too. खैर क्या ही फर्क पड़ता है. Okay, step 3, design deep dive. This is the step 3 of explaining our approach of rate limiting. The high level design in figure 4.12. Where is 4.12, bro? Yeah, ये तो थोड़ा high level design ही है बस. High level पे देखा है. We have a client. We have client के बाद कुछ है हमारे पास middleware. Middleware का दो वे संबंध है Redis के साथ. एंड देन मिडलवेयर का वन वे संबंध है एपीआई के साथ. ये है हमारा हाई लेवल पे रेट लिमिटर. पर कुछ क्वेश्चंस नहीं हुए आंसर. हाउ आर रेट लिमिटिंग रूल्स क्रिएटेड, वेयर आर द रूल्स स्टोर्ड, हाउ टू हैंडल रिक्वेस्ट दैट आर रेट लिमिटेड. ठीक है, रूल्स देखते हैं. LYFT open sourced their rate limiting component. We will peek inside of the component and look at some examples of rate limiting rules. Domain messaging descriptors, key message type, value marketing. What the hell is this? Request per unit समझ आ गया बस. Unit है हमारा day में. हाँ ये तो समझ आ गया. This is a nice whatever this is. Request per unit है 5 and unit है हमारा day. So there are 5 requests that are allowed per day. है ना, request per day हो गया because your unit is day. Man, I'm so dumb, bro. क्या जरूरत थी इसे समझाने. In the above example, the system is configured to allow a maximum of 5 marketing messages per day. Here is another example. हाँ भाई, लिखा हुआ था. Why the was I yapping, bro? Domain auth, descriptors, key auth, blah blah. इसमें इसमें मैं नहीं बोलूंगा. This rule shows that clients are not allowed to log in more than 5 times in 1 minute. Rules are generally written in configuration files and saved on disk. Exceeding the rate limit. In case a request is rate limited, API is return a HTTP response code 429. भाई अब तो याद हो गया. 429 is the HTTP response. It is rate limited. ठीक है. कौन है bro मेरे रूम के बाद? Depending on the use cases, we may enqueue the rate limited request to be processed later. For example, if some orders are rate limited due to system order, we may keep those loaded. ठीक है. Rate limiter headers. How does a client know whether it is being throttled? And how does a client know the number of allowed remaining requests before being throttled? The answer lies in the HTTP response headers. The rate limiter returns the following HTTP headers to the clients. X rate limiting remaining. The remaining number of allowed requests within the window. X rate limit. क्या बोल रहा हूँ? X rate limit remaining. The number of remaining allowed requests. ठीक है. X-ray limit, it indicates how many calls. ठीक है. X-ray limit, re-entry after the number of seconds. Oh, when a user has sent 429 limit ready after header, I return to the client. Retry after header. This is actually so like अच्छे से डिजाइन है. ये रहा डिटेल डिजाइन. पहले हमने हाई लेवल पे देखा था and now we will see a detailed design. 21 minutes, bro. अब ठीक है. I'll just do this, bro. 47 हो गए. हाँ ये समझ आ गया. 3 टर्म्स हैं. एक्स रेट लिमिटिंग है बेसिकली. एक्स रेट लिमिट रिमेनिंग है बेसिकली अमाउंट ऑफ रिक्वेस्ट दैट आर रिमेनिंग फॉर अ पर्टिकुलर यूजर within the window. And X rate limit है, it indicates how many calls a client can make per window. And X rate limit retry after the number of seconds a client has to wait before they can make a request again without being throttled. ठीक है. 429 रिटर्न होता है. दिस इज अ डिटेल डिजाइन क्लाइंट है. रेट लिमिटर मिडलवेयर है, रेडिस है, सक्सेस ब्ला ब्ला, कैश रूल्स हैं, वर्कर्स रूल्स। रेट लिमिटेड हो गई तो ऑप्शन 1 है रिक्वेस्ट ड्रॉप, ऑप्शन 2 है मैसेज क्यू, एंड too many requests are done. ठीक है, rules are stored on the disk. Workers frequently pull rules from the disk and store them in the cache. When a client sends a request to the server, the request is sent to the rate limiter middleware first. Rate limiter rules in the cache, but the counters and match themselves for very cache based on the ये तो समझ आ गया था पहले. Rate limiter in a distributed environment. Building a rate limiter that works in a single server environment is not difficult. However, scaling the system to support multiple servers and concurrent threads is a whole different story. There are two challenges, race condition and synchronization issue. Race condition, as discussed earlier, the rate limiter works as follows at the high level. Read the counter values from results, Redis and check. ठीक है. Race condition can happen in a highly concurrent environment as shown. Original counter value है 3. Request 1, read counter, check counter increment, counter 4 and request to counter. ठीक है. Counter should be 5 होना चाहिए. Assume the counter value in Redis is 3. If the two requests are concurrently read a counter, before either one of them writes the value back, each will increment the counter 1 and both requests believe they have correct counter value for hours. Locks are the most obvious solution for solving race condition. Our locks will significantly slow the system. Two transitions are commonly used to solve the problem. Lua script and store sets data structure in Redis for readers interested. Yeah. Lua script and stored sets data structure. Sets data structure. Synchronization issue. Synchronization is another important factor to consider in a distributed environment. To support millions of users, one rate limiter server might not be enough to handle the traffic. When multiple TikTok-wise, when multiple rate limiter servers are used, synchronization is required. For example, on the left side of figure 4.15, the client 1 sends request to rate limiter 1. As the web tier is stateless, clients can send requests to a different rate limiter as shown on the right side. Bro, this is cheating. With no synchronization. Nah, this is cheating. Sticky sessions that allow random. Performance optimization is common topic in system. We will cover two areas to improve. First, multi-data center setup is crucial for rate limiter because latency is high for users located far away. Most cloud services are, for example, cloud cloud. ठीक है. Second, synchronize data with eventual consistency model. Monitoring after the rate limiter is put in place, it is important to gather analytics data to check whether the rate limiter is effective. Primarily, we want to make sure the rate limiting algorithm is effective, the rate limiting rules are effective. For example, if the rate limiting rules are too strict, many valid requests are dropped. If in this case, we want to relax the rules a bit. In another example, we notice our rate limiter becomes ineffective when there is a sudden increase in traffic like flash sales. In this scenario, we may replace the algorithm to support burst traffic. Token bucket is a good fit. Yeah. Step 4, wrap up. Yeah, in this chapter we discuss different algorithms of rate limiting and their pros and cons. Algorithm discuss a token bucket. Okay, I have my eyes closed. I'm saying the names by memory. Token bucket करा, where we did leaking bucket वाला है ना, क्यू थी जिसमें, and then we did क्या करा था, fixed window counter algorithm. उसके बाद हमने करा था sliding log, और उसके बाद करा था sliding window counter, है ना, sliding window. Yes sir, sliding window. Oh, सारे बता दिए. Then we discuss the system architecture, rate limiter in a distributed environment, performance optimization, monitoring, yeah, hard versus soft. Hard, the number of requests cannot exceed the request can exceed the threshold for a short period. Hey yo, what the hell? What is this, bro? ये क्या है भाई? जब ये करना ही है, what the fuck? Rate limiting at different levels. Application level पे HTTP layers है. It is possible to apply rate limiting to other layers. For example, you can apply it IP address using IP tables. ठीक है भाई, OSI मॉडल 7 लेयर होती है, पता है मुझे. IEDP NDP ये नहीं, IEDP नहीं, IEDP नहीं होता. क्या होता था? नेटवर्क डेटा फिजिकल, नहीं आईडीपी तो होता था। व्हाट वर द सेवन वन? आईईडीपी एनडीपी करा था मैंने कुछ। एनकैप्सुलेशन, डेटा एब्स्ट्रैक्शन, पॉलीमॉर्फिज्म, व्हाट द इनहेरिटेंस, अरे यार आईडीपी तो होता है। सेवन वन साइलेंस यार, आई फॉरगॉट ब्रो। एपीएसटी एनडीपी, यस। एपीएसटी एनडीपी, एपीएसटी एनडीपी, एप्लीकेशन प्रेजेंटेशन, ट्रांसपोर्ट नेटवर्क डेटा एंड फिजिकल, डेटा लिंक एंड फिजिकल, सेशन लेयर, सेशन। ठीक है, एप्लीकेशन प्रेजेंटेशन सेशन ट्रांसपोर्ट नेटवर्क डेटा लिंक फिजिकल, 7 लेयर ब्रो। अवॉइड बीइंग डिजाइन और क्लाइंट विद बेस्ट प्रैक्टिस। ठीक है, कॉन्ग्रेचुलेशन। ये सब आई विल स्टडी, मैं यार पढ़ूंगा ये ब्रो। आई विल स्टडी ऐसे ही, मे बी आई डू लाइक ऐसी वीडियो। बट हाँ, टाइम हो गया ऑलमोस्ट 8, सो आई गो नाउ। बाय बाय बाय। बाय बाय।